Alrighty, I believe I'm recording here. Okay, guys, so the first video for Unit 4, I talked about graphing exponentials. Second one, I talked about graphing logarithms. So here we go. Here's my overview. And this will also contain the practice problems. So, graphing an exponential function. Well, what do they look like? What's the format for an exponential? It's y equals a, which is the scalar, times b, which is the base, to the power of x, which is the variable. Now, when it comes to graphing an exponential, the base value is never equal to 1. So this stuff over here on the side, I wanted to include all at one time. Exponential functions, the base is not equal to 1. Also, the base value that you use for b can never be negative. So in our book, they say greater than 0. If your graph is going to look like this one here, which is decay, that only happens when the base value you use is between 0 and 1. What type of numbers are between 0 and 1? Well, 0.2, 0.7, 1/2, 3/8, those kind of numbers. Numbers that are between 0 and 1 are called like proper fractions. If your base is in that range, it's going to have a decay look to it. But if the base number is bigger than 1, 1.2, 1.8, 3, 8.9, anything bigger than 1, you're going to get a growth model out of that. So your graph looks like that. So in the big grand scheme of things, you either have a graph that looks like this, or you have a graph that looks like this. Either way, you have an asymptote on the x-axis. So when you guys do your practice problems, always mark the asymptote in your graphs for me. But, like I promised, every single time we graph an exponential function, you're going to plug in the same exact x values. Plug in these guys, -2, -1, 0, 1, and 2. And if there's a scalar out in front, guess what? Adjust the scale, but you don't adjust it on the x. Your x will never change. You're always plugging in the same exact x values. The scale is only going to change on the y. So remember that. And if you're going to use your graphing calculator to practice and check your answers, remember you're going to go to the window to make those changes. And also, when you're done checking your work, you might want to zoom standard to reset your window. Okay, what do you do then? Eventually, you're going to get some points that you can plot, and you always connect the dots with a smooth asymptotic curve. That's what it looks like. Okay, so graphing exponentials, there's an overview. Here's the practice problems I want you to do. It says graph the following exponential functions, make a table of values. We're going to just work in decimal. Round all decimals to the nearest tenth. Adjust the scale if needed. So here we go. You use your calculator either in classic mode or math print. I don't care. But you're going to punch in to your calculator. Come on, straight. Is it not going to straighten up? Oh my gosh. Okay, fine. You're going to plug in -2, -1, 0, 1, and 2 for every single one of these. Get your output, round it off to the nearest tenth. If there's a scalar, then adjust your scale. So if there's a scalar, adjust your scale, etc., etc., etc. And then you'll have 7 pictures there. Then let's switch gears. Let's go to logarithms. So here we go. I wrote this out for logarithms. When you're going to graph a log function, once again, you have a scalar, you have a base, you have a variable, something you plug in. Once again, for a log function, we never let the base equal 1. And Similar, but not the exact same as an exponential, when your base value is a proper fraction, so it's between 0 and 1, you're going to get this look. This guy right here, swooping down. And you can see I put a little asymptote action there. And if the base value is bigger than 1, you're going to have this type of guy. So it's swooping down, right? Huh? So very similar in a completely opposite way is how logarithms behave. What numbers do I want to plug in here? The same thing as I did in my examples. Always use these numbers, 0.1, 0.5, 125, because they're always going to give you plenty of information to draw the graph. They're not hard to plug in. And do remember that your calculator is only programmed to understand base 10. So you might need to trick your calculator into a different base, and that's called the change of base formula. So log x divided by log of whatever the base is. Log x, whatever you want to plug in, divided by the log of whatever the base happens to be. Connect the dots with a smooth asymptotic curve. Oop, asymptotic, I forgot the S. Okay, anyway, here we go. Here are these questions. So there's 8 of them here. And you will notice that every single problem here has a base written in, except for one of them. There's no base written in, which means this thing would have a base of 10, which is called the common log. And this is already programmed into your calculator, so you don't have to do any trickery with it. That's the button log, what it was designed for. However, let's suppose you want to enter this into your calculator and get it to work. Just a reminder, we're going to use, for my x values, 0.1, 0.5, 125. So if I want to trick my calc, I would say log of 0.1, that's what I want to find out, divided by log of 1/3. Here, hey, I want to trick my calculator into doing this. Log 0.5 divided by log 1/3, etc., etc. So what does it say here? Graph the following logarithmic functions. Make a table of values, just like this, chaw. Round your decimal answers to the nearest tenth. Adjust the scale if needed. So for this one, your scale would be 30. Every dash on the y-axis should be 30. On this one, every dash on the y-axis should be 50. Okay? This guy, the scalar is a 1. They didn't write anything in, so don't change your scale. That's what it means by adjust scale if needed. And then once again, you can check all your answers on a graphing calculator. So that's part of the assignment, is you practicing how to use your graphing calculator correctly. All right, grand total, you have 8 questions here. I'm going to scroll back up. You had 7 questions from here. That means you turn in 15 total completed graphs for me with a table of values. That's your assignment, okay? So this is the video that contains the assignment. All right, good luck.